Consider this word problem. A piece of wood from an ancient burial site has an activity of 30 becquerel. The original activity is estimated to be 240 becquerel. What is the estimated age of the wood? The half-life of carbon-14 is 5730 years. Scientists use carbon-14 to estimate the age of one-time living organisms. Let's have a look at carbon-14. Here's the half-lives. Call this textbook, and here is carbon. And carbon has different isotopes. There's carbon-11, carbon-12, 13, and here is carbon-14. And carbon-14 has a half-life of 5730 years. If it's not radioactive, it will have no half-life. So carbon-14 is radioactive. Carbon-13 has no radioactivity. And carbon-12, as we know, is stable. And there's also carbon-11, and it has a very short half-life of a mere 20.3 minutes. The one that is used in order to determine the age of one-time living organisms is carbon-14 at 5730 years. Considering this word problem, we have a piece of wood. Okay, let's have a look at a piece of wood. Here is the earth. Excuse me. And on the earth here we have a tree. And a tree has roots. And carbon-14 is an isotope of carbon, and a tree is made up of carbon and hydrogen and oxygen. It also contains carbon-14. And the earth in here is also some amounts of carbon-14. And as the tree grows and it is alive, it is doing an intake of carbon-14. But carbon-14 being radioactive, it is also decaying and leaving the tree. But there is a cycle that goes on here. As the tree is alive, it will maintain a specific level of carbon-14. Once the tree dies, and we'll just draw it this way, and here's the roots. Once the tree falls over, it is no longer intaking carbon-14, and the carbon-14 that was already within it is now decaying. And scientists are using this information, the original amount, while it was still alive, had to have maintained a specific level. Then once it dies, the carbon-14 will start to decay and will decrease over time. And this is what is being used in order to determine the age of once living organisms. This can be done for, well, you and me, trees, and other living organisms. The equation we're going to use for this, since we're talking about activity, here at activity, we're going to use the activity equation. A is equal to A naught e to the minus lambda t. Given the information, let's write down what is given. We'll do that here. This is A. The activity today. That's what this one is. After a period of time, this A represents the activity as of today. So this tree died some time ago, and the carbon-14 has been decaying. How much carbon-14 is left over today, or the activity that is left over today, that's what A is. And it says here, it has an activity of 30 becquerel. That is today's activity. It's estimated, A naught, that the original activity was 240 becquerel. That is what it originally started at before it died, or at the time when it was alive before it died. Original activity is estimated to be 240 becquerel. Lambda can be determined by ln of 2 divided by the half-life. And that's equal to ln of 2 divided by 5730 years. Let's have a look at that. Do that calculation on our calculator. Clear this. Ln of 2 divided by 5730 is equal to. I'm going to put all these values down for lambda. 0.000120968 per year. Year is in the denominator, per year. And we have time. And that is what we're looking for. How long has this tree been dead? Time. We have what we need. Just a matter of putting these values now into our equation. I'm going to do down here, putting in the values of A, 30 becquerel, is equal to A naught, 240 becquerel, e to the minus, and if there's a mistake made, it's made right here by not including the minus lambda. Our value for lambda is this term. Per year times the time. That's what we are seeking. At this stage of the game, let's isolate e to the x. Let's isolate this one. So divide both sides by 240. 30 becquerel divided by 240 becquerel is equal to e to the power of minus 0.000 times t. Becquerel and becquerel will cancel out. And the way to bring this power down to the base is to do a logarithmic function. In this case, we're going to do a ln or log base e. Log base e, also known as ln. So we're going to take the ln of both sides in order to bring this down. The power's down. Doing that, it will look like this. Whatever I do to the left, I have to do to the right. So taking the ln of the left-hand side of 30 divided by 240 is equal to the ln of e to the minus 0.000120968 t. Need to continue on a separate page. When we take the ln of an exponential function, the powers will be brought down, and it looks like this. On the left-hand side, ln of 30 divided by 240 is equal to minus 0.000120968 t. The whole exponent will be brought down, times the ln of e, times the ln of e. Let's have a look at ln e using our calculator. I need to do the ln. There's ln. And I need to do e. E is e to the power of 1. Remember, any number to the power of 1 will give you the base. 5 to the power of 1 is equal to 5. 10 to the power of 1 is equal to 10. So e to the power of 1 would be the value of e. Need to find e to the x, second function. E to the power of, now make that 1, is equal to 1. So the ln of e is simply 1. Makes life easy. Having that as 1, I'm going to rewrite the equation. Becomes the ln of 30 divided by 240 is equal to minus 0.000120968 times the time, which is what we are seeking, and 1. Having reduced the equation to this form, we need to divide both sides by this term in order to isolate time. ln of 30 divided by 240 in brackets divided by minus 0.000120968 is equal to t. Oh, I forget, this is per year. Just backtracking a little bit. Now let's put this in our calculator. The ln of 30 divided by 240. And put ln of, I need to put brackets here, 30 divided by 240, close that bracket, is equal to, and it's a negative number, and that's a good thing because we're going to divide by a negative number, divided by this term. That's minus 0.00120,968, and that's equal to 17,190. 17,190, and the unit here is in the denominator, and I showed you this in a previous video. It's going to come to the top, years. So time is equal to 17,190 years old. And lastly, we need to put this to proper significant figures. Going back to the original word problem, the activity was measured to be to 2 significant figures, and it's estimated to have started at 2 sig figs, estimation, and the half-life is to 1, 2, 3 sig figs. So we need to use the least number of sig figs, which is 2. So we need to round this to 2 sig figs. It's approximately 17,000 years old. Therefore, the wood at the ancient burial site is approximately 17,000 years old.